Okay, so hi everyone. I'm going to talk about open source framework called Wake, and we are developing it in Ackee, which is a company I'm co-founder of and I'm running. We are smart contract auditors, quite small team based in Prague, and I always say that the good auditors audit, the best auditors write open source tooling. Thanks to Trail of Bits that are on this way, Open Zeppelin, and we are trying to contribute as well. So we are working with some kind of, I would say, high-profile players, such as Safe, Axelar, 1inch, Pendle, and this is something I want to skip. It's too, yeah. And here I would like to speak about the Wake framework. Our motivation basically was that we kind of like the tooling such as Slitter or Brownie, but we wanted to have this all integrated. And you can understand Wake as a Swiss tool, and our goal is to basically replace Brownie as a testing framework because it's not maintained anymore. Then we are providing fast testing with some special features such as cross-chain testing. And then we have a static analyzer such as Slitter integrated. And the advantage of having these two together is that we can work with the outputs. So we have implemented a language server, and that allows us to have like single front end, which is extension called tools for Solidity. So now I will deep dive into the single features of the framework. So first of all, static analysis in Wake. The output of the command line static analysis in Wake looks like this. So we wanted to make the output very readable and pretty. So basically, this is one detector. Here is the name of the detector. And we also have here impact and severity. And it's easily marking the line where is the possible issue. So these are the outputs of the static analysis. We have right now about 20 detectors, so not that much, but our motivation is to have the most precise detectors, which means we prefer 0 false positives over many detections. Because of course, when the static analyzer is doing a lot of false positives, no one will be using that. So we have some specific detectors, for example, for 337. Which is checking forbidden opcodes and access. Usually how we work is that when we are auditing a project and we reach some problem that can be automated, we write a detector for that. So that also explains that we have a lot of detectors for Axelar or Safe, because these are the ecosystems that we are present in. We did one detector which is pretty common, and we did some small benchmark here. It's a very small benchmark, it's just 50 random contracts. And this detector was actually written by one of my students at the university. So we have right after right detector, which is kind of like typical. And as I said, like our motivation is to focus on the precision, which means the ratio of false positives should be 0. Not that much on the recall, which is the number of detected issues of all issues. You can combine these two metrics in something that's called F1 score. So in this benchmark, we were kind of lucky, but of course it's a very small benchmark. We will be happy to have some kind of like unified benchmark suite so the analyzers could be competed against, but maybe a step for the future. We have also printers. Printers are basically detectors that are just for the auditors to see some kind of like pretty output. And this is, again, command line output of our storage layout printer. So it's kind of like handy for the auditors during the auditing. We are telling that the Wake framework is like development and testing framework, but the secret message is it's mainly useful for auditors because it allows a lot of tools that are helpful during auditing, and this is why we create it, because we use it ourselves during our audits. So this is the static analyzer. The second part is the testing framework. So as testing framework, basically, we love Python because in Python, it's very easy to write tests. And the trick Wake is using basically is that we have also intermediate representation of a smart contract that's being generated from the Solidity code. And this internal representation is in Python using PyTypes, which means we can be easily interacting with the contract with Python syntax like this. And as it's in Python, it also shows all typos, and it's also showing suggestions while writing the test. So it's very easy and fast to write the tests in the framework. And basically, we started developing this even when Brownie was maintained, but now it's not maintained anymore. So big kudos to them, but we think we are kind of like replacement for this. The other added value of the PyTypes integration is that we can be using all the Python tooling. So for example, call traces. So here basically we are debugging the Solidity code completely in Python. And also, I hope this animation runs. No. Can we just turn the animation? Sorry. Video. It's a GIF basically, but. Okay, so looks like no animations. It's showing IPDB debugger in action with Wake. So sorry, I think we are not able to play that. I know. Yeah, and now it stopped. Sorry, can I get some help with the presentation? Yeah. Yeah, it's a GIF. No, we are presenting from the web. No, it's a link, or is it? It's a PDF file. Okay, I wrote that. I have animations. No. Okay. Yeah. So I just need to open the link I've provided. So can I connect my computer? I need an animation. Yes. You need it. Okay. Yes. Because I have more. But we are presenting from the. No, it's PDF. No PDF. Let's see if it works. And can I open the URL here? Because I've sent it to the URL source open in the browser. This is not my email address. I have to resend it to this one. Here it is. Can I just in this browser open the URL that I sent here? There is no URL. Sorry. I sent you the email and the email is URL and I need to open it here. My email address. Is it uploaded online? Or you email? I sent it on Telegram to her and email. Okay, thank you. Sorry for the inconvenience. Now we are back and let's see if it loads. Yes, so this is what I wanted to show. So basically this is in action. As you can see, we are using IPDB debugger, which is a Python debugger, and we are debugging a Solidity contract. And it's very easy just to look at all possible values. And it's also suggesting. And this way we can debug basically Solidity in Python. Suggestions work. Okay, the next part is fast testing. So I guess you're familiar, for example, with Foundry. So basically our approach is very similar to Foundry, but we as Python maxis prefer writing fast tests in Python. There are some advantages. For example, we can be generating grabs from Python, or as a Python is, I think, kind of like faster language to write tests in than Solidity. And our approach to fast testing is kind of different, for example, from Echidna. We call our fast testing something like guided fast testing, which is not black box fast testing. The difference is that with black box fast testing, the tester defines invariants that are the assertions that cannot be broken. And then the fuzzer is basically running based on some heuristics or AI or any other magic through the state space, which can take a long time and it can stuck in a loop. In our case, the tester writes not only invariants, but also something we call flows, which are basically instructions where the fuzzer should be fuzzing and which data. So you can understand it as, for example, try this sequence of these functions with these inputs. It's not necessary to try all possible characters, but just like cut it to some limited set. And by this, the fuzzing is very fast. So basically, of course, it needs some tester interaction, so he needs to write the code. But then the fuzzing campaign takes like maximum hours, even on the local node. And we can do more. Maybe you're familiar with differential fast testing. It's basically a fast testing against some model. So in our case, we write in Python, for example, the mathematic formulas based on the documentation. And then we are just running the fuzzer. And the fuzzer is comparing results from the smart contract and from the model created in Python. And for example, in DeFi, there are a lot of rounding errors, which are very hard to find by just reviewing the code. And this differential fast testing is very helpful. We have discovered plenty of issues in protocol Hyper, for example, using that. And the test is kind of simple. So basically, just from the documentation, we rewrite the code in Python, which is very easy. And then we compare it using the fast test with the contract outputs. I try to make a little bit overview of the fast testing frameworks, at least how we see that. So basically, Wake is not a black box, it's a guided fuzzer. Invariants are sometimes called also property-based testing, so all the testing frameworks are using invariants. We are Python maxis, so we like writing code in Python. Another thing is cross-chain support. We have a support for cross-chain testing because we audit, for example, a lot of projects on Axelar, so we needed to be able to fast test like from one chain to another, which I know that in some frameworks is complicated. And also we have something called custom rewards, which means we can define how the function rewards, which is also very handy in debugging. So that's the fast testing part. Now about the performance. So does it work? Quite yes. These are some of the findings we have discovered just using the framework. It doesn't mean by manual code review. So it's either by fast test or by the static analyzer. And it's in Python. So the question could be, isn't that too slow? The answer is not. We have made another test. We have implemented 271 unit tests of Uniswap v3 in three different testing frameworks. They were originally written in Hardhat, and we just implemented it in Brownie, Ape, and Wake. And we have run this test suite against 3 deployment chains, Anvil, Ganache, and Hardhat. And the testing performance is crucial, because when the tests take long, it will not be easy for the developers to use it, and it will not be efficient to have it, for example, in CI/CD pipeline, because when the build pipeline takes long time, every time you turn off the test, because it's slowing down the pipeline. So here we managed to run the test suite in 3 seconds, compared, for example, to Brownie, which is 34 seconds. So we have like 10x. We are approaching this thanks to something we called differential compilation, which means we are not compiling the whole code base every time, but just like the differences. Here's a little bit like an overview from the zoom out perspective. So the goal, as I said, is basically to cover all the parts of the ecosystem. Of course, we are not telling that this tool is doing it the best way, but we are just like trying to create a Swiss knife. And as I said, we also have the language server, which is the front end for the tooling. So this is the extension called Tools for Solidity. If you are using VS Code, you can install it. And the advantage is that by one click, it just installs the framework on the background. So all you need to do is just to install the extension. And here we can see visually all the findings from the static analyzer in real time, which means the developer or auditor doesn't need to run CLI tool. It just instantly pops up in VS Code when there's some finding. We are also highlighting the issues, so when there is a problem, it's basically shown in real time. And thanks to printers, for example, we can do some advanced formatting natively in VS Code. So here we can easily print public functions. So it's a printer implemented in Wake that is communicating through LSP server with VS Code, and VS Code is displaying it as native object. We can also make a visual test coverage of the contracts. And yeah, these are the extensions compared. So as we started, of course, the latest, I think our extension is now covering both the development and security part. And we are still maintaining that, and we'll be happy for any feedback as well. So if you would like to explore more, here are the links. So we have documentation, we have GitHub, we have some ready-made test suites. So I'll give you some time to take a picture. And yeah, I made it in time, so thank you. And I guess we can have some questions. Yes?
Thanks, great presentation. Is the virtual machine in Python, like for the execution part?
No.
Okay. What do you use?
We are just like using the source compiler.
But for the execution, like you
Okay, for example, we are using PyTypes. So basically, it's like we are using native Python.
Okay, native Python.
So that's the advantage. Then we can use all the tooling that Python offers. And
Have you compared the execution against Foundry?
Sorry?
Have you compared the execution time with Foundry?
execution times with Foundry compared, not really. We have compared just the test suite of the unit swap we test, but like we are of course aiming to be very fast. And Python is not the main problem. The main problem is usually the architecture. Right. Yes.
So you use the right after right vector as a precision metric. What does that mean in a high level?
Nothing. It's just the one detector that we have benchmarked, so don't take this as a metric of all others. That's of course the open question, like what would be really helpful to have like a very massive test suite that all the tools could use. Yes, please.
Foundry has this cool mode where you can just test online contracts by forking off the mainnet state. Is there something similar in Wake?
Yeah, thank you for the question. I wanted to speak about it later in the panel. Fork testing is very important for the integrations. So, for example, when we are auditing a project that is using Chainlink or Aave, then if we would be just testing as a mocks, it's not real testing. So how we do it is we are using Anvil as a development chain, and then we are integrating like the archive node with Anvil, where we fork the chain. So for example, when we call some contract that is not, of course, deployed in Anvil, it asks the archival node and just loads that storage and everything from the archival node. So this is very useful, and we are using it a lot.
You mentioned cross-chain testing. Is it just about running tests with two different RPCs, or do you have the ability to test things like chaining CCIP?
Yeah, the main motivation is, of course, to test the segments of transactions on both chains, which is, I don't know, if you're auditing a bridge, then you need to make sure that when something happens on the chain A and see the result on chain B. So this is cross-chain testing.
But then you need, for a bridge, you would need to still write the bridge logic or mock to be able to test it.
Not really. We just write fast tests, and either then we just as we run the Wake framework, it generates the PyTabs representation, and this is the thing that we are calling. And if it's not enough and there's some integration, then we can use the fork testing for the retrieval of the data. If I understood. We can follow up. Yeah. Okay, so I guess slow.
If there's no more question, I just want to. So let's say we're testing a bridge that you do something on, you send something to a contract on Arbitrum, and it pops up on a contract on Ethereum. In the real life, there's
Yep.
going to be a program watching events on one chain and sending transactions on
Yep.
the other chain. But I want to run a local test with these two chains. So I still have to have the logic of the bridge running alongside the tests for the test to be able to prove that when this thing happened on chain A, that's forking localhost 8545, something else happened on chain B, localhost 8546.
I think that's exactly what I said. So basically, yes, you need to have a local deployment, but local deployment is done automatically by Wake, because it generates all the interfaces and PyTypes. So you just run Wake init over the contract, and it creates the internal representation, intermediate representation model, which is the Python representation of the both contracts, and then we are just in the fast test, calling both chains as an instance. So this is how we do it. There's if you look at the dots, we have specific there one section about cross-chain testing, and there's a demo on this exactly like you asked. Okay, thank you very much.